Hello and welcome to the IIT JEE Advanced 2019 Paper 2 Mathematics Solutions. Now the most troubling part of the advanced, that is the maths paper. So let us see what are the troubling areas and what were the question asked. So coming to the first question first, so let us see here what is the first question. The first question is related to the limit, and it is given that f is a function from R to R, and the property 1 is defined if this limit exists and is finite, and the property 2 is defined when this limit exists and again it is finite. Now there are four functions which are given to us. The function number 1 which is given is x raised to the power 2 by 3, and the second function is mod x, and again the third function is x mod x, and then again it is sin x. So we have to see which one of the following option is correct. So let us check for the first option. Here it is x raised to the power 2 by 3, and we have to check the property number 1, and this is the property number 1. So limit here h is tending to 0 and f of h. Now what is f of h? It is h raised to the power 2 by 3, and what is f of 0? It is equal to 0 definitely upon that is under root of mod of h. Now if you see this is a positive quantity, and you can see here this is in turn equal to modulus h 2 by 3 minus 1 by 2. So 2 by 3 minus 1 by 2 is definitely equal to 1 by 6, and this is definitely tending to 0. So definitely the limit exists and it is defined and it is finite. So option A is correct here for us. Now let us check for the option 2. It is modulus of x. So again checking for the property number 1 here, we have limit h tending to 0 mod of h minus 0 upon under root of mod of h. Now if you again check, this is under root of mod of h, and this is again tending to 0. So again the limit is finite and it is existing. Coming to the third one, it is x mod x. Now here we have to check for property number 2. So in property number 2, what is given here? In place of under root of mod h, it is h square. So this is a change here. So we are going to check for the option number 3. So it is h tending to 0 x mod x. So it is h mod h minus f of 0 is again 0 here, and here we have h square. Now you can see if you cancel out one h here. Now h can be positive or negative. If you are looking for the left hand side, that is 0 minus, this will give you minus 1 value, and again for 0 plus, this will give you plus 1 value. That means the left hand limit and the right hand limit are different. So the limit is not existing here. So limit does not exist because left and right limit are different. So option 3 is incorrect. So far we have option 1 and 2 correct. Option 3 is incorrect. Now let us check for the fourth option, that is sin x. Again it is limit h tending to 0. Here we have sin of h minus 0 upon h square. Now again you can notice here the sin h by h is definitely 1, but again 1 by h, this is 1, but 1 by h is tending to infinity. So definitely the limit is not finite. So the fourth option is again incorrect. So we have option A and B as correct option. Let us move to the second problem. So here we are on to the second problem. It is again a function which is the product of three factors, x minus 1, x minus 2 into x minus 5, and we have to check which of the following options are correct. and we have to see for the local maxima and minima. So definitely we are going to differentiate this function, and this can be done without integration. So let us differentiate this. The derivative of the function, that is capital fx derivative, is definitely the derivative of x, that is 1 into x minus 1 into x minus 2 into x minus 5. So let us check where this derivative is 0. The critical points are 1, 2 and 5, and you can notice here the derivative is positive here, again negative, and again positive and negative here. So the function is decreasing up to 1. So the nature is this. Again it is increasing up to 2, and again it is decreasing, and again it is increasing. You can very clearly see that the function is having local minima at x equal to 1 and maxima at x equal to 2. So very straight we can see A and B options are correct. Now we have to check for C and D. Now definitely D is not correct. It is saying f has 2 local maxima and 1 local minima from 0 to infinity. So now let us check for the third option. Fx is not equal to 0. Now we have to integrate. Say if I am looking for this maximum value, so I am going to calculate f of 2. If I am calculating f of 2, it will be integral from 0 to 2 ft dt. So if you calculate this value, the value will come out to be minus 10 by 3. Now the function is easily integrable, and you can find the value, it will be minus 10 by 3. Now we can apply a simple logic here, that is the maximum value is negative, and if you calculate the function, the value at 0 will be equal to 0. By putting x equal to 0, the value at 0 will be definitely equal to 0. So we can see the value at 2, that is the maximum value at 2 is negative. So we can easily say that fx is not equal to 0 for any value lying between 0 to 5, because at 2 other values, that is at 1 and 5, we have got local minima, and the function being a continuous one, the maximum value is negative. So the minimum value will be more negative, and definitely the function is not going to become 0 at any point lying between 0 to 5. So the third option is again the correct option. Let us move on to the next problem. Now here we are on the question number 3, one of the most hated problem of IIT Advanced 2019. Problem related to the matrices, as there were a lot of calculation involved. Now what is given? P is a matrix, Q is again a matrix with the variable x, and R is a product of P, Q and P inverse, and we have to check all the 4 options here. Now all the options were quite tricky, and we need to calculate each and every one individually. So first we are going to check the first one. The determinant of R is equal to sum of determinant of 2 quantities, that is determinant of this matrix plus 8. Now we know a very important property, that if we want to calculate the determinant of R, it will be equal to the determinant of P, Q and P inverse. So determinant of R here will be equal to determinant of P, Q and P inverse. Now again we know the property, it is determinant of P, determinant of Q and the determinant of P inverse, and the determinant of P inverse is 1 upon determinant of P. So this will cancel out. So in a way, determinant of R is equal to determinant of Q. Now we need to split Q into 2 parts. This is one part and this is another part. Now Q is given here. Now you can notice here, you can observe all the terms here. There is one term which is changed. Here it is 6 and here it is 5. So definitely you can split this determinant into 2 parts. So what I am going to do here, let us see, we have to calculate the determinant of Q. So what we are going to do here, it will be determinant of 2xx 0 4 0 x x 5 plus it will be determinant of again 2 x 0 4 x x, and I am changing this column. This will be 1, this will be 0, and this will also be 0. Now, if you calculate the value of this determinant, it will be straight away 8. Now, this is again this one. So, you can easily see the first option is correct. So, determinant of Q is equal to determinant of this matrix plus 8. So, first option is the correct one. Now, let us check for the second one, again a tricky one. It is given that x equal to 1, there exists a unit vector alpha I cap, beta j cap and gamma k cap, for which R into this matrix alpha, beta, gamma is equal to a 0 0 0. Now, a null matrix. So, what we can check here? If there is a R and if there is again alpha, beta, gamma, for which this is true, and if it is true for x equal to 1, definitely you can see that this system of equation, a homogeneous system of equation, this is 0 0 0, these are variable alpha, beta, gamma. So, R is there, and you can notice that if the solution is there, if the non-trivial solution is there, then the determinant of R has to be 0. So, we are going to check what is the value of x for which the determinant of R is equal to 0. If the determinant of R is equal to 0, we will have alpha, beta, gamma, for which we have this unit vector. So, let us check here. If you check the determinant of R, you know the determinant of R is equal to determinant of Q, and we have already calculated it is 8 plus this one. Now, we need to calculate this determinant. So, let us see what is determinant here. We need to calculate it. So, let us see what is the determinant again here. If you expand this determinant, you will easily see this determinant plus this will be 48 minus 4x square. Now, as I have said, the determinant of R has to be 0. So, from here we have x square is equal to definitely 1 2. So, x is equal to 2 root 3 or plus minus 2 root 3. So, determinant of R is equal to 0 for x equal to plus minus 2 root 3. So, definitely this is not the value which is given, it is equal to x equal to 1. So, the second option which is here for us is the incorrect one. So, the second option is the incorrect option, that is for x equal to 1 we have this alpha, beta, gamma. Now, we are going to check the third option. Now, for the third option we need to calculate this R first. So, let us see how to calculate this R. Now, it is given here for x equal to 0, this R into this matrix 1AB is equal to 6 times 1AB. Now, for that we have to calculate R first, and you know what was R here. So, we have here R 1AB is equal to 6 times 1AB, and we have to see what is the value, that is a plus b is equal to 5. Now, for calculating R, as you know, R was P, Q and P inverse. So, we will be calculating P inverse first. If you calculate P inverse, it will be 1 by 6, 600, and here it was minus 330, and it is 0, minus 2 and 2. So, P inverse is this. Now, we have to equate this, that is here it is P, Q P inverse into 1AB is equal to 6 times 1AB. Now what we have to do further, P is known to us, Q is also known to us, the value of x is given, that is 0. P inverse we have already calculated. Now this will give you a matrix of third order, which when multiplied with this, that is this is of order 3 into 1, you will get again a matrix of 3 into 1. Now equating with this is 1AB, equating with this you will get two equations in A and B, and if you calculate the value of A and B, you will get value of A equal to 2 and value of B equal to 3. So this will give you A plus B is equal to 5. So again the third option is correct, although it was quite a lengthier one. Now looking for the fourth option. Now let us check for the fourth option. The fourth option, it is given there exists a real number x for which PQ is equal to QP. Now P was given to us, this is P, and Q is also given to us. So let us form the equation here. So we have to check whether there is x for which PQ is equal to QP. Now let us do it. Again a calculator one. P is 1, 1, 1 and it is 0, 2, 2 and again 0, 0, 3. And what is Q? Q is given to us is, let us see what is exactly Q. It is 2xx 040 xx5. So it is 2xx 040 and xx6 is given to us. So let us check whether it is 5 or 6. Yes, it is 6 here. So again this is P into Q, and here this is Q again, and here we have to write P. Again P is 1, 1, 1, 0, 2, 2 and 0, 0, 3. Now we need not be calculating the entire matrix product. We have to check whether there is a real x for which this is true. If you observe it, you can see the first element is going fine, but if you check the second one, that is this element, that is A12 element, here we are going to check the A12 element by multiplying this and this. You have x and again it is 4 and again it is x. So here we have, it is x4 plus x, that is 4 plus 2x. So this is coming out to be 4 plus 2x. On the left hand side again we are going for this one and we are going to multiply this. You can see it is 2 plus 2x and again 0. So it is 2 plus 2x. So if you check this element, that is A12, it is again not equal for any value of x. So definitely the fourth option is not the correct option. So far we have the correct option as definitely the first option is a correct option. We have already checked for this. So this is the option which is a correct option, and again option number C is also the correct option. Let us move on to the next problem. Here we are on to the next problem. It is related to the local maxima and minima, a function which is involving a periodic function sin pi x. So there are many critical points. So these critical points or the points of local maxima are related with x1, x2, x3. They are denoted with, again y1, y2, y3 are the points of local minima. Then we have to check whether the local maxima, the first local maxima is less than first local minima. Again the difference between the two consecutive local maxima is greater than 2. Again the difference between two consecutive local minima is greater than 1, and the interval in which the local maxima is lying. So definitely we have to first differentiate the function. So let us see here, f dash x is equal to, applying the division rule here, it is x4. Now here we have sine, the derivative of sine pi x is cos pi x into pi into the denominator, that is x square minus 2x into sine pi x. Now taking common from here, so let us take here x we can cancel out. So we have x cube, and again taking 2x common from here, and again also cos pi x common. Let us see what we are having here. It is pi x by 2 minus tan pi x. So this is what we have, equating that to 0 for the critical points. You can notice here, although this is equal to 0, x, and again this is the third factor, but again you can see x equal to 0 is not in the domain, and from here cos pi x is definitely not equal to 0, because again this tan, or you can see the derivative is infinite here. So we are not taking these critical points, we are going to take these critical points, that is tan pi x is equal to pi x by 2. Now we have to see, now the critical points we can't easily find out because there are two different type of functions. Here it is tan and this is the linear function. So what we are going to do, we are going to have the graph of this. We are going to see the intersecting points of this line and this function, and we will see what are the critical points. A very trickier problem, and we have to see where x1, y1, x2, y2 are related. So please note, in the problem it is given x1, x2, x3 are the points of local maxima, and y1, y2, y3 in the increasing order are the points of local minima. So let us have the graph first here. So let us see the graph of y is equal to tan pi x and y is equal to pi x by 2. So here is the graph for us. You can notice here that tan pi x, this is the graph of tan pi x, and the graph of y is equal to pi x by 2. So y is equal to pi x by 2 and the graph of y is equal to tan pi x. Now let us see the cutting points. This is the first cutting point, which is lying between 1 to 3 by 2. The second cutting point is definitely lying between 2 to 5 by 2, and so on. Now again we will have alternate maxima and minima. So let us check for the first one. If you check the derivative, if the derivative of the function, that is in this interval, this is the first point, it can be x1 or y1, because x1 was the point of local maxima and y1 was the point of local minima. So the first point, which is lying between 1 to 3 by 2, if you check the derivative of the function, in the left hand side of this point, that is this particular point, say this point is a point k, x equal to k. If you check on the left hand side, you will see this is lesser than 0, and again by checking on the positive side, this will be greater than 0. So this point, which is lying between 1 to 3 by 2, you can see the derivative is negative, then it is positive. So definitely this is the point of local minima. So this point is y1. So first y1 you can check, this is the point y1, which is lying between 1 to 3 by 2, and again the next point which is lying between 2 to 5 by 2. If you check the derivative again at this point will be definitely point of maxima, and this will be denoted as x1. Now again we can check for further, and this is going to repeat. You can see that you will have alternate local maxima and minima. So we can see which are the following options are correct. The local minima is lying between 1 to 3 by 2. The local maxima is lying between 2 to 5 by 2. So the first option, if we check here, that is y1 is greater than x1, this is definitely incorrect. If you see the difference between two maxima that is greater than 2, you can easily check. This is also correct, and definitely this difference is also greater than 1, and this is also correct, and definitely the local maxima is lying between an even number plus 1 by 2, as we have seen here that it is lying between 2 to 5 by 2, so that is also a correct option. So option number B, C and D are the correct option. Let us move on to the next problem.